And he's been back for a little while, and Aaron's got a really interesting demonstration for us tonight and presentation on Swift, the Apple programming language. Aaron.
Thank you. Okay. Step one. Okay, nope. On auspicious beginning. Wrong cable. Let's do this right. Bear with me here. You see me all right there, Chris?
Yeah, go with close-up.
You go with close-up. So when Brian says I went into the wilderness, what actually happened is the desert, yeah. I decided at that time that I wanted to learn how to program Apple stuff. And at the time, I was a web developer, which is someone who builds websites and web applications. But that wasn't satisfying to me, and I wanted to learn more. It turns out that learning to program the Mac and then later iOS to build applications for them is a hardy endeavor. It's not easy, and it required all the focus and time I could give it. And I was giving a lot of time to this club. As much as I love you guys, I did it for years, and I felt that I needed to spend time focusing on this. So I hope you don't take it wrong, but I left the club, and now I've come back. And I can share some of your... I'm an honorary life member. I've never left. Right. Be that as it may, I was asked to tell you a little bit about maybe a bit of what I've learned over the years. And basically what they're asking for is Swift. And has anyone heard of Swift before I walk in the room? Hey, hands, Ian, come on.
No.
Okay, don't raise your hand then.
No.
So there's a handful of hands. A handful of hands.
That's safe.
Yeah. Yeah,
Not
it's
even slightly.
not even a little bit. That's fine. I'm a little dubious about bringing this to you guys because it's a broad and a very deep topic. It has taken me years, probably 5, 6, 7 years, to get to where I am today in terms of knowledge. And
It's about 10 minutes. So.
oh yeah, you've got 20, so twice the time. And I feel like I'm just scratching the surface, to be honest with you. I am applying my skills professionally at Walt Disney, so that's great. But I just know that I need to learn more and more and more and more. And so what I'm going to give to you tonight, basically, is the very basic introduction as to what Swift is, the context of Swift as a programming language, and a little glimpse of what it looks like to build an iOS app. Let's dive in.
Go.
Did I hear a yo? Go! Oh!
Go swiftly.
Okay, so very quickly, what is programming? So basically, programming is the process that people type crap into their computers and make it do stuff. It's really that simple. You can operate a word processing program, but it's a programmer who actually makes the word processing program that you can type into. It's pretty straightforward that way. You can think of anything that you do with a computer, and the idea is that, wing, it's built of a lot of different levels. So from your app, at the very top of this, imagine a layer cake, it's the icing. The app is the icing. It's got a whole bunch of crap underneath, and let's start at the bottom. So like, you look at the very basic language that CPUs speak, which are the brains of your computer. It speaks in binary. It's ones and zeros, right? It's full of registers, and they're either on or they're off. And programmers manipulate those registers. At least back in the very earliest days of computers, that's what they did. And that's how they got computers to do stuff. But as you can imagine, writing ones and zeros is really inconvenient, and nobody can really do that, really. So they created a layer on top of that, and that's machine code. And machine code are the special instructions that a computer uses to translate programmer's intent into actual action. My slide screwed up here, so I'm just going to actually take the picture that I had, and there. Imagine that picture sitting on that slide nicely. This is what machine code looks like, all right? Basically, it's just a bunch of commands. It basically moves memory around. These are all memory addresses, and it gives a command to memory, and it doesn't look like anything to you. It doesn't look like anything to me either. This looks like gibberish. So don't worry. If you think in gibberish, I'm also thinking gibberish, but this is what moves computers around to do different things. Go away. Bye. Okay. Now, let's get to something real. Programming languages are what you write. Programming languages are compiled down into that machine language I saw earlier, which is then compiled down into binary and then told to do stuff on computers. So what you're seeing here is Swift. This is Swift code, and it is performing a particular action. And I'll take you a little bit further into this in a bit. There are tons of programming languages. There's no shortage of them. Swift is just one of many, many, many. Here's a list. If you've ever heard of any of these names, then you've heard of a programming language. Congratulations.
Is Swift Apple only?
No. Swift was designed and built by Chris Lattner, an engineer that worked at Apple. He left, went to Tesla, then left Tesla. Don't know what he's doing now. But it is an open source language that is now available for multiple platforms, including Linux, and there are ports being made for other platforms as well.
You're missing one up there that I use at home on my Commodore PET. It's called BASIC.
BASIC, yeah. I got BASIC in here, don't I?
Visual Basic.
Mm.
Visual Basic. C++.
Yeah. I'm not going to lie to you guys. I just like whatever language I can think of. There's thousands of them. You go to Wikipedia's programming languages page where it has a list of all the known programming languages, and it's a very long page. Okay. So programming languages have particular things in common. The idea is that they're human readable. Like you're supposed to be able to, write in it and read it. That's the whole point of it. It's not machine code. It's not binary. You don't need to be a mathematician to understand it. They're also compiled into machine code. So a language like Swift, which we'll obviously get to, is converted into that machine code that you saw and then run on a processor. And then one of the scariest things about programming languages, and the things that separate people who program from those of us who don't, is the fact that they are incredibly logical. That they, like a genie, jokes or stories about genies granting their wishes. A computer is just like that. It will take exactly what you say and do that. And that isn't always what you want. And so part of the task of being a programmer is figuring out your intent and then giving the correct instructions to the computer to do that. Programming languages have certain features. No matter what programming language you look at, you're going to see something very similar to what you got up here on this board. There are types of data. There are numbers, which are integers. Integer is a whole number. A float is a decimal point number. There's strings, which are characters. There are dictionaries, which are like collections of keys and values. So like eyes equal blue, name equals Aaron, Brian equals sitting in chair, And arrays, which are index types. So I've got a list of computers that I own. And it's a Mac, an Apple Watch, an iPhone, and like on. So those are types. Variables are like algebra. You assign values to variables. So like x is 12. You can assign that. And so then you can use that value later on in your application. Name is Aaron. Aaron is in quotes. It's a string. There are conditionals, because if you have different circumstances, you want to do different things. This example here is if x is equal to 0, then do something, and I'll give you instructions for that. There are control structures. So if I've got a collection, like an array of things, I can iterate over each one of them and do something. And then there's functions and classes, where I can take a group of lines of code and put them under one function and run them all as a unit. Like this one, do something, which returns a type of string, and then there's the body of the function that returns, quote, done, exclamation mark, unquote. Those are programming languages. That's what they all do.
You would see done, you would see Aaron.
Yeah.
Okay.
I think the next slide is a demo. It's as if I wrote this presentation myself. Let's take a break. I'm going to introduce you to something called Xcode. Xcode is Apple's integrated development environment. It's the program that you use to write the programs. And with Swift, it has a feature called Playgrounds. And Playgrounds Don't suppose it matters, but anyway. Yeah, okay. I always want to know, save it where? I don't know. Okay. A playground is like a scratch board or a scratch pad, where you can write code, see the results, test things, see if they work, play around. It's a playground. And so let's do an example here. I'm going to run something here. Playgrounds. Hello world. Don't open over there. Perfect. Okay. So I'm going to start by creating an array. Okay? Get rid of that. This is very awkward for me because I have to look at the screen behind me. But see, here's an array. This array is a list of all the executives of this esteemed club. All right? Oh, thanks, Chris. Just with my back to you guys. But this is better. This is better. Okay.
You were smart there.
I know. Yeah. I hate my side profile. Okay. Now, to that, we've got some data. Let me add another piece of data, greetings. And this is an array as well. This is an array of different strings. Hey, what's up? Greetings. What are we going to do with that? I'm going to create a control structure. Let's start it off like this. Okay. So you saw that example in the earlier slide. This is going to run through all the mouse executives using this variable named exec. So say Michael's an exec. Just say. I know this is asking you to stretch, but there it is. Okay, so let me take one of those variables. And this isn't going to work right now, but you're going to have to bear with me. So I'm going to create a new variable called greeting. And I'm going to call a function, which I haven't written yet. And then I'm going to print this here, like that. So I'm going to print one of the greetings to one of the execs in turn. To make this work, there's this random number, which is a function, which I'm now going to show you, which takes a random number between 0 and the value of the size of the array. Here it is. And you can see the results down here at the bottom. Can you see that?
Yep. There you go.
And I can run it again, it'll run it again with different results because it's random, right? Yeah. You're in Ahoy this time. Greetings, Ian. You with me? All right. Okay, so just to back up here. You're able to see that okay back there? Okay. I guess that's one benefit of having the smaller room.
And a bigger screen.
It is such a beautiful screen. So the idea here is that I'm taking, for every exec in this array, so by turn it goes through each one of these strings, I get a random string from this array. So there's the greetings and there's the greetings. And then this square bracket notation is like, give me, because an array is an ordered index, goes from 0, 1, 2, 3, 4. Give me a random number out of greetings count, which is 4. And then it gives me the greeting back, which I print there. Clear as mud, am I right? No. This is the simplest program I could think to write for you.
You could have done that in BASIC.
I could do it again in Ruby. I could do it in Python. I could do it in C. I could do it in Objective-C. I'll do it in whatever language you like.
Swift.
Done. Okay. So let's go back. Okay.
Very cool.
Swift. What's the deal? No, seriously, what's the big deal with Swift? So the whole point of Swift is that it is the new language from Apple. It's about 3 years old now. It was introduced in 2014. And it came after Objective-C, which was Apple's primary development language from the time that Apple bought Next in '97. Next was the computing platform that Apple purchased, which came with Steve Jobs' return to Apple back in the late '90s. And it also bought their operating system, Next, the Next OS. And Next became the foundation for Mac OS as you know it today. So that operating system became Mac OS. So too, all the development tools from Next became the Mac OS's development tools. And it was a hell of a deal. They spent $400 million, which everybody said, oh my good Lord, how can you spend that much? It was a good deal. It was a very good deal. And so Objective-C, which is kind of an outlier in many ways. I'm not going to spend any time going into it, but Objective-C is a very strange language to people who know programming languages. And so it turned a lot of people off and probably wouldn't have gained any credibility at all if it weren't for iPhone. When iPhone came out, it became, of course, the most powerful and popular computing platform in the world. And so people had to learn it. But it had some, issues that people didn't like to deal with, which is why Swift exists now. The whole point of Swift, if you listen to Apple, is that it's easier to learn than Objective-C, which might be true, but it's safe. They love to talk about safety. That stuff I talked about earlier about types, data types, many programming languages don't really care if you handed a string or a number to a variable. They're like, oh, whatever, we'll figure it out in the end. Swift needs to know. Do not mess with Swift and variables because the types have to be known. Don't mess. You'll see some of that, I hope. Maybe I'll show you some of that as we go on. And of course, the reason that you need to know Swift is if you want to play in Apple Sandbox, you got to write in Swift. Any native application that you build today should be written in Swift. You can still write in Objective-C if you want. Nobody's going to stop you. You could write in C if you wanted, which is an even earlier programming language. But Swift is the way to go if you're doing something new today. Stop me if you have any questions.
May I ask a question?
Oh, yes. Stan.
Are they then going to convert all the old programs to this new language?
An excellent question, Stan. Excellent question.
Which means?
No. Yeah. It's fair to say that any app that existed in 2014 when Swift was introduced with a sufficiently large code base was likely to stay in Objective-C. We're talking about a lot of work to update a program or change a program so it's using an entirely different language. It's a massive undertaking. And so basically, people would only use Swift if they're starting a new program from scratch. And so even Apple's own apps, basically their own apps are still written in Objective-C. So like you think of Pages or even Xcode, some of their large code bases. They're still Objective-C today. But Apple has made it so that you can actually mix the two languages in the same application as you're writing it. So I could have this part of the app that is written in Objective-C. It's old and busted, but it still works. But over here, if I'm adding a new feature, I can write it in Swift, and both can exist in the same application. Okay, let's move on. Okay, in the world of real-life apps, the language alone is not the consideration because anybody can learn a language, and it's actually not that hard, especially if you've seen a language before. Most languages, as I've shown you, are very similar, conceptually speaking. They have types, they have control structures, they've got all the things I showed you. What makes development difficult and complicated and scary is the fact that you use frameworks. And this is something that Apple provides to develop on their platforms. To give you an example, these are libraries of code that you can call into with your code to make things happen in your app. If you are writing for the iOS platform, for phone or for iPad, you're going to use a framework called UIKit. And UIKit is the framework that provides the views, the tables, the collections, the images that you see, buttons, labels, text fields. All those things are part of UIKit. And so when you're using an app that has these things that you recognize, they look familiar, like a button here looks the same as a button in a different app. A table view, which is just a single list of items that you can scroll, they look the same everywhere because it's the same component. It's brought to you by UIKit. And developers use those components to build their apps. And I'm going to show you some of that in a bit. If you're developing for the Mac, it's called AppKit. AppKit existed first, obviously. UIKit is like the new hotness, although it's getting old now. And then Foundation is sort of the underlying kit. It provides all of the primitives that you would use to create arrays, manage arrays, do networking stuff, for example. A lot of basic stuff is in Foundation.
Is there a question for you?
Yep.
Is a framework like a pre-prepared part? So.
Did you use the word pod?
Part.
Part. Okay.
So, like, instead of, like, for instance, you would buy a brake and a brake pad for a car, you wouldn't start making them. A framework would be the disc and the brake pads.
That's an interesting analogy. And to someone who is completely oblivious to cars, it's difficult.
Oh, you.
This guy.
Okay.
But let me put it to you this way. Do you remember the example I showed you a few minutes ago where I wrote that function, random number, right? And it's a thing I called out to. Now imagine UIKit is actually like a whole library of functions like that you can call out to. So like not only random number, but like first number, last number, things like that. And it does all kinds of different things that are sort of related.
But what I'm trying to get at is, does a framework do a pre-organized thing? So you have a program, a framework to turn it blue, or to turn
The framework could
to English or something.
possibly, yeah. There are frameworks. The frameworks provide different functionality, which could or may not include those examples that you just stated.
Well, I'm thinking of anything.
Of course you are. So it's not anything.
But it's pre-written to do a certain
Correct.
thing. So you don't have to, the framework's made up of 30 parts, but it's one thing. You don't have to make each 30 parts,
Right.
because you go to framework number 30.
Okay, well, why don't you sit tight for a second, and I'm going to show you an example, real life.
Okay.
And then once your socks have blown off and you pick them up from this side of the room, then we'll see if you're where you're at.
Is it really that bad?
Any other questions? Okay.
Okay.
Demo time, Ian. Okay. I'm done with, oh no, I still need that, so I'm going to keep that. But what I'm going to do now is I'm going to create a new Xcode project. Yep. And this is going to be an iOS app. I'm going to create you an iPhone app right here, right now. Are you ready for that?
Can we sell it?
Yes. You certainly could. And to do that, I'm going to create a new Xcode project. And you can see Xcode has templates for many different types of app, right? I'm going to use the single view application. You can see iOS is selected. I could create a watchOS app if I wanted to, tvOS app, macOS app. I'm going to create a single view iOS app. The simplest. That's what we're here for. 20 minutes. Super fast, simple. Got to name the thing, and we'll call it, what am I doing here? Temperatures. Because that's what I'm making. And you see it fills certain things out. And the language is Swift, not Objective-C. You remember that? Remember Objective-C? Yeah. History. We're using Swift. Devices, it could be iPhone, iPad, or universal. Apple recommends that you build universal apps these days. If the app runs on iPad, it should be able to run on iPhone too. I'll leave the rest. So hit next, and then find out where to save the darn thing, and then create. Okay. So what we've got here is an app that provides some places where you can write some code, and something I want to show you called Interface Builder. An Interface Builder is a visual programming environment that lets you create objects that appear inside of your apps, hook up code to them, and then actually works on a phone or a device, whatever. Okay? So the application that I want to create right now, I love it when things work. Okay. The application I want to create now is a very simple temperature converter. You put in Celsius on one side, it spits out Fahrenheit on the other, right? And I'm going to create like a slider that can drag things back and forth and show you the results. So here we are in Interface Builder, and I'm going to start dragging out components. So a text field, and here we are. See, this is like a library of UI components. I just drag it out there. I'll create a second one for Fahrenheit. Say that one's Celsius, that one's Fahrenheit. I'll create a label. Okay, see that? That's a label. Just put it in between there, and I'll, which one is it? That's it. So that'll be degrees Celsius. I'll create another one. Do you see how simple this is? This is a joke, man. This is why, like, crazy kids in their basement are making apps. Okay? Making money. So that'll be Fahrenheit. Okay? And I'll create a default value here, 0. And you know what 0 Celsius is in Fahrenheit? Straight up. Okay? The other thing I'll do is get a slider. You guys seen slider switches in iOS apps before? Volume controls, for example. So here's one. Pretty straightforward. I'm going to put that there. And let's create a button. Button. I'm going to put that there. And this will be a reset button. So if I just want to go back to default. Reset, man, not rest. There's no rest for us. We're working too hard. And you know what buttons look like. So far, so good? Now, I can run this right now. And it'll actually show this. Do you guys want to see that? How do you even do it? Okay, hit play. It's like iTunes. I remember when Xcode 5 or something came out, and it came out with this new UI. It looks like iTunes. And this is an iPhone 7 Plus simulator, which I will shrink down because holy cow, look how big it is. And it's loading it up right now. See? Ta-da, right? And that's what it looks like. Simple, right? Now, as you can see, it doesn't actually do anything. You know? It doesn't do a damn thing. Let's make it do a damn thing. So this is the part where we start writing code. And the code is all provided by UIKit, the framework that I was telling you about. And it's a view controller. This is a class which combines a bunch of functionality into a single unit. And this controls the behavior of the thing that you see in that particular window.
Can you stop for a minute?
No, I'm not stopping. I got 20 minutes, Chris.
Why are there a bunch of numbers on the side of the screen there?
Oh, these lines. The line numbers here.
Yeah, what's that for?
Okay, so line numbers are really important for programmers because if there's an error and the compiler stops you, and I'm going to be so good you're not going to be able to see that. But knowing the line number reference is actually really helpful to programmers because then you can talk to other programmers and say on this line. Okay, so the first thing I'm going to do is I'm going to create a few variables in here. And they're notated with this IB outlet keyword, interface builder outlet. And an outlet is a connection between a variable and the thing on that visual layout that you saw. Ian, are you ready for your socks to be blown off? Because here we go. I'm going to hold down Control on my keyboard, and draw a line from the view controller symbol to there, and make the outlet connect to the Celsius text field. Do it again, Control, drag to the Fahrenheit text field. And then again, from the view controller to the slider, the temperature slider, all right? And those things are now hooked up. I can now access those values from code. That's the whole point of it. Let's go back to here. And the next thing I'm going to do is I'm going to create the actions that you can perform with the app. The first one is the slider, okay? And that's going to be to change the temperature. So we don't need this one. We don't control memory at this point. We're basic, man. This is an IB action. See the difference? IB outlet, which is a connection from code to UI. And an IB action is a connection from elements in the UI to the code again. So when I push a button or move a slider, it's an action that my code executes. And just like this, I'm going to go back to the storyboard. Control me, man. Okay, here it comes. And I'm going to control drag from that slider back to the view controller and select that event. Change temperature with sender. Okay? And then, back in here, you can see that it's going to perform these actions whenever somebody takes that slider and moves it around a little bit. Okay? It's going to run the code in this method. Right? Now, let's have a look at that. I'm going to read the Celsius value from the temperature, which I should probably go back and actually make work, you know? That's probably important. Let me back up a bit. This slider here can be modified over here. Has properties, okay? So the value right now, I'm going to set it to 0 with a minimum value of minus 100 degrees Celsius and a maximum of 100 Celsius. Okay? So the whole point here is I want to be able to show you Fahrenheit values for conversions between Celsius, negative 100, and positive 100. Okay? That's all I need to do. Okay. So here's what I'm doing. I'm taking the value that the slider's been set at. I'm rounding it because it's going to come in as a float value with a decimal place like of 6 to 8 places. It'll be nuts. So I'm just rounding it down to basically a whole number. I'm going to lose some precision here in the math, so just ignore that part. And then I'm going to take the Celsius text field and I'm going to set that value to what the slider says it is. Then I'm going to get the Fahrenheit value by using some code I haven't shown you yet to convert the Celsius to Fahrenheit. All right? And I'm going to round that, and then I'm going to take the Fahrenheit text field and I'm going to set its value to what I get back from the converter. So far, so good. But wait! I don't have a converter yet, so we got to create one. And I'm going to do that by adding a new file, a Swift file, to my project. I'm going to call it converter with 1 T, you know. Why? Okay, so that's that. And I'm going to go back over here. I'm going to copy some code. And I've written a converter that does a few conversions, a few different conversions. I'm only going to be using one, though. And so this is what it looks like. And you see, if you recall correctly from my view controller, I'm using Celsius to Fahrenheit. And this one has Fahrenheit to Celsius if I wanted to do that. And I thought, maybe I'll just do some weight measures as well. But you can kind of get the idea that these functions, they're doing very basic math, straightforward math. And that's what programming math looks like. It's pretty simple. And so this is one I'm actually going to be using. It takes a Celsius value, which is of a float type. It passes back a float type. And before that, it does this math on it, which I think is a formula that you probably recognize. So with that in place, you can see that converter doesn't freak out the compiler anymore, and it's pretty much ready to run. Let's try it out. Please work. This is a live coding exercise, so nothing could possibly go wrong. I grab the slider. Oh my good Lord. Look at that.
Take it down to minus 40.
Minus 40.
It should be the same.
Yeah, see, that's the precision I was talking about. Told you. You know what I'd love to do right now? I'd love to reset it. Oh, but nothing's happening. I haven't done anything yet. All right? Okay, let's fix that. Because the way to fix that would be to write a method for the reset button. And you're in luck. I've done that.
You've done this before, Aaron.
Seems that way. So that's what that looks like. And it's very straightforward. It just resets the fields that you know and love to their initial values and sets the temperature slider to 0. And then what do I have to do before this works? Because it's not going to work right now. I have to hook it up, right? Brian, you're up. You're with us. I dig how you're paying attention. So it's take the reset button and draw reset temperature with sender. Right? It's a miracle! Yeah, that's right. And I swear to God, you could like put a nice fancy background on that, give it a brand name, 99 cents on the App Store, and Apple would accept it, and then you'd be a millionaire.
Yeah, I was going to say 300,000 or 400,000 of those for sale.
Yeah. Yeah, so let me see here.
How much do you get if they sell it for 99 cents?
You get 70 cents of that 99 cents.
Holy cow.
They get 30, you get 70.
You have to sell a lot of copies to make any difference in your life, my friend.
What was it, what they paid out in December?
Oh, yeah. Yeah, Apple likes to talk about how much money they've given to developers ever since the App Store opened. Yeah, it's gone to like 8 people. Sure as heck hasn't come to me. So if you're interested in this stuff, and there might be 1 or 2 people. What's that?
Said you knew Audi, I saw it.
No, no.
He wrote it.
I'll just finish by showing you some resources if you're interested and you'd like to follow up. Like I said at the top, this is an extremely deep topic. It is so deep that you could spend years. And I will spend years. I'm going to spend the rest of my life doing this. I'm not kidding you. But here's Swift, Apple Swift page, which is a good starting point, but not a great starting point. I guess I should... computers, how do they even work? Come on. Okay. So this is... oh, there you are. This is Apple's Swift page, and it's got some starting points for you. These are resources. The first thing you would have to do, of course, is download Xcode, because Xcode is the thing I showed you that lets you write the apps. Another place to go, a couple of things I like. Big Nerd Ranch, which is a company based in Atlanta, and they've done training. They actually used to be a Next OS training company. And so they came along for the ride to Apple. And they've written some of my favorite books. My very first programming books are Big Nerd Ranch books. If you want to learn about that, they've got kind of 2 that you could look at. The Swift Programming Big Nerd Ranch Guide, or the iOS Programming Big Nerd Ranch Guide. Both terrific books. And no. Look, sit beside your computer, pore over it, read it 80 times, and maybe get a gleaming of the understanding from it. And finally, though, but this is probably one of the most interesting resources, and certainly Apple would love you to do it. This is going to bounce me out to iTunes, I'll bet. I bet you this is exactly what you do. This is a course that Apple has just put together. It's brand new. About, hang on 1 second. Again, here we are. This will open up in iTunes. You can get this on your iPad, and they're basically textbooks. You start off with app development with Swift, or intro to app development with Swift. That's a teacher guide. I think this is the one. These 2. See these 2, the colored ones? Those are the ones you want. Start with this one, then go to that one. And that'll give you a good grounding. They're very good.
What, the iTunes U courses?
Yeah, I think these are, aren't they?
There's books for it.
They're the books for it.
Books for the courses.
Okay.
But there's the full course as well. Right? These are the resources for the course.
Oh, really? Okay, not familiar with that. So the iTunes U app on your iPad will have the courses that you can take, and will point you to these books.
Resource for the course.
Right. So I'm a textbook learner. I need a book to learn something. Everyone's different. There are also, if you look out on the web, you'll find videos. The Stanford University has a wonderful computer science course, which is iPhone development, and it will take you through from start to finish, and you can take that class for free. It's a great resource. There's no shortage of ways that you can learn how to program with Swift. I'm wrapping up. I'm done. Look at me. I'm done. Any other questions?
Question, there's a couple of questions here.
Okay. Brian, yes.
Got one. You and I touched about this briefly in the waiting room at the Volkswagen dealer. We're on version 4 of this right now.
Swift version 4 was announced at WWDC,
Yeah.
so it's not what actual professional developers are using right now.
Okay. And it's been a little bit rocky in terms of stabilities of 1, 2, and 3.
Right.
Are we confident about 4 now? And are you seeing an uptick? Are you seeing an uptick in terms of adoption that would reflect that?
Yeah, I think so. Swift 1 came out in 2014. Swift 2 came out after with a bunch of changes. Swift 3 came out the year after that with colossal changes. But now it's stabilized. It's still changing, and there will still be changes, but it's not going to tear your life apart to go from 3 to 4. and it won't tear your life apart to go from 4 to 5. So it's fine. You can get in now. There's a question here.
Well, also, I know it would be a very, very simple beginning, and you wouldn't be programming sort of standalone iPhone applications from it, but there was a program for the iPad called Swift Playgrounds.
Yeah. Yeah. So you saw the playgrounds that I was bringing up there. Yeah, that's the inspiration for Swift Playgrounds for iPad. And Swift Playgrounds for iPad is like a guided tour of Swift with some prepackaged lessons that you can kind of go through. It's really aimed towards children in a lot of ways, although anybody could benefit from it. But there are like, consider animations, you know, like here's a character, you're going to write some Swift code to move the character through a picture, and it kind of works like that. But it's available for free on the iTunes App Store, and you can go and download it and try it out if you like. But if you're going to do it for real, you got to get a Mac.
Thank you.
Okay.
Now, did everyone who's entitled to a raffle ticket get one? Everyone? Yes or no? People back here?
You gonna start calling out tickets now?
Yep.
Nicely done.
Anybody else? Okay, you've had a chance to look at the raffle items. There's a couple of Macintosh computers there. The portable is a G4, 1.13 gigahertz, and it works really nicely. It was donated by Jeff Hurd.